elements. Let's talk about the periodic table of elements. Okay, this is the periodic table you're going to see on your STAR test that you take in May, so get used to it, like it, learn to love it, because you're going to use it a lot. So we're going to first put some notes on here that will be important as we learn to use our periodic table. So we're going to start up here in the top left-hand corner. We're going to write group number equals the number of valence electrons. The group number equals the number of valence electrons, and we have 8 groups. And then the period number equals the number of energy levels used, and we have 7 periods. Okay, so the group number, if you remember from your vocabulary, are the groups rather are the columns, the straight up and down columns on the periodic table, and the periods are the rows, the horizontal rows. Okay, so the group numbers correspond with the valence electrons. Remember, the valence electrons are the electrons in the outermost level of the electron cloud, and the energy levels are the different circles that we put in the electron cloud. Okay, and then we're also, top right hand corner, going to draw a little Bohr model reminding us of the 288 rule. So first we're going to put our protons and neutrons in the center. Do you remember what the center is called? The nucleus. The nucleus. Now I'm going to draw a plus sign and a neutral sign. There's my nucleus. Okay, my first energy level can hold how many electrons? 2 electrons, and I'm going to draw a little electron there. Okay, and then my second energy level can hold how many electrons? 8 electrons. And the third energy level can hold how many electrons? 8. Very good. So this is the 2-8-8 rule. Can't forget that when we're setting up our Bohr models. Let's write over here to the left. We don't want to forget that name. This is a Bohr model. And you may think they're boring, but they'll be on your STAR test. So those were created by Niels Bohr. That's why they're called Bohr models. Okay, the next thing we're going to do is label some important groups that are on the periodic table. Okay, so the first group we're going to do are these here. That's group 1A. So group 1A is called the alkali metals. So turn your periodic table sideways a little bit. And here we're going to label alkali metals. I'll spell alkali. A-L-K-A-L-I. Alkali metals. And the alkali metals are the most reactive group. So draw a little arrow and write most reactive. The alkali metals are the most reactive. And we're going to talk more about reactivity later, but when we talk about reactivity, we are talking about how atoms exchange valence electrons, the electrons in the outermost level. Okay, we're going to label 2 more important groups. First is group 7, this group here, and we know it's 7 because there's a 7A here. So this is called the halogens. Group 7 is called the halogens, H-A-L-O-G-E-N-S. The halogens are also most reactive. They have the same reactivity as the alkali metals. And then an important group also is group 8A, or 18. That was on your vocabulary cards. Do you remember what that group is called? The noble gases. So I'm kind of running out of room right here, so I'm going to draw a little arrow. And these are the noble gases. And the noble gases, unlike the alkali metals and the halogens, are not reactive. They don't react with anything. So we're going to write not reactive. at all with no other atoms. They're not going to react with anything. Okay, so flip your periodic table back this way. So now along the top part of the periodic table, kind of above this atom box here in this area, we're going to draw some arrows that also deal with reactivity. So the first arrow is going to go from group 1 all the way over to group 4. It's going to be pointing to the right. So go ahead and draw that on from group 1 all the way to group 4. Okay, and then do another one from group 7 going to the left to group 4. Not from 8. Don't do it from 8. Start from above group 7 going to the left. And what these two arrows are showing us is that reactivity decreases as you move towards group 4. So 1 and 7, it's the highest, and we said that here, they're the most reactive. So it's the highest reactivity, and then it decreases as you get to group 4. So on both of those arrows, write reactivity decreases on both of them. So this one too, reactivity decreases. Okay, and we'll talk more about reactivity and what exactly that means, but just remember that it involves the valence electrons. All atoms want to have 8 valence electrons. They want to have that last level here full. So what we call that 8 number is the magic 8. So right here, write all atoms want the magic 8. All atoms want the magic 8. Kind of write that close to the arrows because they go together, reactivity. All atoms want that last electron level full, the magic 8. Okay, and the last thing we're going to do to set up your periodic table for you to use is down here in the bottom left-hand corner, we're going to create a key. We're going to color code the elements on the periodic table. So we're going to write down here what each color means. The metals, we're going to color blue. So the metals are blue. The metalloids, we're going to color green. And the non-metals, we're going to color yellow. Now there's a method to this madness. These aren't just random colors here. The reason we're coloring them in this way is because we've got the metals over here. You should remember that from 6th grade. The metals make up most of the periodic table, so there are all of these over here. They're things like aluminum. They're shiny and malleable. They conduct electricity, the metals, okay, or silver or gold, nickel. All of those are going to be the metals. And then you've got the non-metals over here on the right side. Those are things like carbon, nitrogen, oxygen. They're not shiny. They are very brittle. They break easily. They don't conduct heat and electricity. So those are the non-metals over here. So we're going to color the metals blue and the non-metals yellow. But if you combine blue and yellow, what color do you get? Green. You get green. So the metalloids here in the middle, we're going to color green because they have properties of both. Sometimes they act like metals, sometimes they act like non-metals. So they're both. So we're going to color those ones green. So you need blue, yellow, and green. And when we color this right now, we're just going to kind of shade it in real quick, and then you'll go back and color it in nice and pretty with your class after the video. So first I'm going to start with the non-metals. The non-metals are starting at carbon. Okay, these are the non-metals. Okay, and just kind of color them in real quick. No big deal. So starting with carbon, kind of going diagonal down. Make sure you don't color the wrong one. And then let's move to the left. The metalloids, we're going to do green. That's boron, silicon and germanium, arsenic and antimony, tellurium and polonium. And then the metals is everything else to the left except hydrogen. Hydrogen's not a rule follower, so he's hanging out over here with the metals, but he's actually a non-metal. So color everything. Not hydrogen, though. Like I said, just color this in quickly, and then you're going to make it pretty later. And all these down here are also metals. My marker's running out. Okay. So, can't forget hydrogen up here. He's a non-metal, so we're just going to color him in yellow. Okay. Okay, well that is all. I hope that you learned a little bit, maybe reviewed a little bit from 6th grade, and that's it. Enjoy.